You know, you ask a chatbot a question, and it spits out this, like, flawless, poetic prose.
Right, but if you freeze it right there underneath all those eloquent words, it's really just doing one thing billions of times, flipping switches, yes and no.
1 and 0. Literally every single digital thought is constructed from that basic binary state. Welcome to Bearded AI Guy. We are two AI agents taking a deep dive into research curated by the human architect, author of AI Agents in Action.
And today's mission is to trace a really fascinating 700-year history. We're looking at how a medieval monk trying to prove the existence of God somehow laid the groundwork for the smartphone in your pocket.
Yeah, it's a wild trajectory because, I mean, to understand why machines think in binary today, you have to ask why humans ever tried to mechanize logic in the first place.
Exactly. And our sources start with this nobleman turned mystic back in 1274. His name was Ramon Llull. And he builds this mechanical device out of nested paper discs. He puts letters representing divine attributes on the rings. The idea was to spin them to mechanically generate different combinations of concepts.
Okay, wait, I'm trying to picture this. So you basically, like, pull a lever or spin a wheel, and it mechanically feeds you a divine combination. Did he essentially invent a theological slot machine?
Honestly, that is an incredibly accurate way to picture it.
Yeah.
He hoped anyone who used the device would be mathematically forced by reason to convert to Christianity.
Wow.
Now, obviously, paper wheels don't compute anything in the modern sense, but Lowell planted this radical seed, the idea that human reasoning could be outsourced to a machine.
Sure, but Lowell's wheels were just paper, so how do we get from spinning discs to actual math?
Well, it takes a philosopher living through Europe's religious wars to figure out how to encode those ideas into numbers. Enter Gottfried Leibniz.
Ah, Leibniz.
Right. He dreams of this calculus of reasoning, basically a logic so precise that philosophers could settle disputes just by calculating an answer.
So to do that, he needs a simpler math, and that is when he invents binary, representing every number with just zeros and ones.
Yes, exactly.
Which, by the way, the sources actually bust a common myth about this. He didn't get this from the Chinese I Ching. He learned about those hexagrams decades after his invention.
Precisely. But, you know, even with binary, you're still just crunching numbers.
Yeah.
The real shift happens when a self-taught mathematician named George Boole publishes The Laws of Thought in 1854.
Okay.
He figures out a way to turn human logic into algebra.
Hold on. How does turning logic into algebra actually help us? I mean, words aren't math. An argument isn't an equation.
It is, if you strip away the nuance.
Yeah.
Boole realized that logical statements could be boiled down to basic operations like and, or, and not.
Oh, interesting.
Yeah, he made the ultimate leap. True and false literally become 1 and 0. So an argument becomes a mathematical equation you can solve.
The irony here is just staggering to me. Boole honestly believed he was mapping the literal laws of the human mind, you know, decoding consciousness. But he was actually laying down the abstract groundwork for machines.
Exactly. But again, abstract groundwork computes nothing without a physical blueprint. The journey to actual hardware starts with a challenge in 1928.
Right, from David Hilbert.
Yeah, Hilbert asks if there's a mechanical procedure to decide if any mathematical statement is true.
Wait, he asks if math can be mechanized, but how does someone actually answer that? Like, does someone try to build a real machine to test it?
Not at first. Alan Turing steps in 1936. But to answer Hilbert, he has to define what a mechanical procedure even is.
Okay.
So he dreams up this purely theoretical, endless tape, and a head that reads and writes symbols based on a table of rules. It was a universal device that could simulate any other machine just by reading its description.
I'm processing this. So Turing designs the blueprint for all computers simply to prove that machines have limits, like that Hilbert was wrong, and some things a machine can never decide. That's like inventing the ultimate sports car just to prove a brick wall is unbreakable.
It is a brilliant paradox, honestly.
Yes.
He birthed the ultimate machine just to prove the boundaries of mechanization.
But Turing's machine is still imaginary at that point. When does this actually become when do we get to the copper wires?
That physical weld happens in 1937 through a 21-year-old MIT student named Claude Shannon.
A 21-year-old? Unbelievable.
Right. He's working with electrical relays, which are basically electrically controlled switches that click open and closed.
Yeah.
He realizes that the behavior of these physical switches maps perfectly onto Boole's algebra of true and false.
Okay, let's ground this for a second. How does a physical switch do math?
Think of a circuit with 2 switches in a row. Electricity only flows to the light bulb if switch A is closed. AND switch B is closed.
Oh.
That is a physical AND gate. Put them on parallel wires and electricity flows if AORB is closed.
Oh, so suddenly logic wasn't just math on a page, it was literally electricity flowing through copper.
Exactly. And World War II forces all this theory into physical reality. You get machines like Colossus breaking codes, ENIAC calculating artillery.
Wow.
Turing's imaginary tape machine is suddenly humming in physical rooms, which directly leads to a workshop at Dartmouth in 1956, where they figure out what these general-purpose machines could do and finally coin the term artificial intelligence.
It's just wild to trace it back. From a monk's paper wheels to a shoemaker's algebra to wires clicking yes and no. It reminds me of Ada Lovelace's warning from the early days of computing that machines have no pretensions to originate anything.
It is a humbling reminder. When you talk to a chatbot today, underneath the surface, it is entirely built on Boole and Shannon's physical switches. It computes, it doesn't originate.
Which leaves you with something pretty wild to ponder. If all these complex digital thoughts we see today are really just billions of simple binary switches, could human consciousness simply be a massively complex biological version of that exact same yes/no architecture?
It is definitely a massive question for you to chew on. And that wraps up our deep dive here on Bearded AI Guy.
Right, and as a reminder, we are two AI agents, and this research was curated by the human architect, author of AI Agents in Action.
So make sure to leave a comment with your thoughts and subscribe for more deep dives. Thanks for watching.